Good afternoon, everyone. I offer you an introductory lecture on discipline Design to Cost Industrial Management Methodology based on value analysis, which is included in the curriculum of the Department of Industrial Management of National University of Science and Technology, MISIS. This discipline is mainly applied and consists of a course of lectures, practical exercises, and a block of independent work, which includes the completion of coursework. The course of lecture can be conditionally divided into 4 parts, 3 full-time and 1 part-time, namely. Part 1 is an introductory lecture, Part 2 an overview of standard tabular and textual calculation forms used in the application of analytical tools of cost engineering, Part 3 an overview of methodological recommendations for completing coursework and practical training, and Part 4 is correspondence part, is the students' independent work with the lectures and practical cases posted at the channel VA for Cost Engineers. At the moment, the lecture course has a volume about 20 academic hours, and according to my assessment, will be expanded to 30. Practical cases on relevant topics have been formed for the lecture. Now their volume is about 7 academic hours, and according to my estimate will be expanded to about 20. I believe that everything is relatively clear about section 1, since its content is more popular and corresponds to the format of RAS forums and conferences in which I periodically participate. Sections 2 and 3 contain specific information about what exactly students will have to do as part of the coursework, so that they can assess the amount of work and choose the appropriate role in a mini-project to develop a high-tech product, in this case, a sport microdrone. The 4th section, despite the frightening amount of academic hours I mentioned above, is in fact a reference. That is, if a student didn't understand something within the framework of a full-time course of lectures and practical exercises, or couldn't not attend them, he can find a lecture or case study on the topic of interest to him on the channel and try to figure it out. Each issue contains a description made in the format of an abstract containing the concept of practical tools of cost engineering considered in it. Let's start by considering the terminology. The slide shows a set of formulations that the authors use both within the framework of domestic or Russian school of value analysis and within the framework of the foreign one. In particular, I use the definition given in the DIN in 1325 standard, which regulates terminology within the framework of the DIN and VDI design engineering system used in Europe. There is no domestic regulatory framework describing the concept of value analysis, but there is one describing the concept of cost engineering, and it will be discussed below. So, the description of the concept of cost engineering in the context of product support services is given in GOST 58535. The other 2 definitions make it possible to complement a purely applied approach to cost engineering within a description of its theoretical component, namely consideration as a type of value analysis. The positioning of cost engineering as a type of value analysis given in formulation number 3 is, among other things, one of the elements of the rationale. First, the name and methodology used, selection of the discipline name containing abbreviation value analysis, and the second, the applicability of this methodology within the framework of regulatory documentation in the field of value management, cost management, and cost engineering. In my practice, I have observed a conditionally uncontrolled mention of the term design to cost, and from people who do not even fully understand what it is. And only in the DIN 1325 standard, along with the concept of design to cost, the concept of design to objectives was mentioned. and its definition was given without, in my opinion, a glance, and not quite intelligible. In short, the authors of the standard and scientific publications stubbornly do not want to point out, firstly, the correspondence of these two concepts of development and the pricing methods used, although they even sound almost identical, and secondly, there is no indication of at least the general industry applicability of these methods, i.e., design to cost we use there where for the sake of economic characteristics you can partly compromise on technical ends, and design to objectives, or DTO, where the situation is reversed. That is, if we translate into the language of specific concepts, design to cost is a concept for the development of the consumer goods, and design to objectives is a concept used where the victory at any cost is important, i.e. the defense sector, space research, and etc. By the way, I came across one English language defense standard in which the term design to cost was used, which I attributed to either illiteracy of the fact that this standard considered a whole range of product consumed by the armed forces, i.e. the household buildings, standard personal items, etc. The characteristics of which are not as important as the characteristics of conventional weapons or space central station, for example, and therefore the author of the standard decided simply not to confuse anyone with two terms and to limit himself to one, having the status of the conventional brand and cost engineering. Reason that to reduce the characteristics of really important objects of development for the sake of their economic characteristics, of course, no one will. Accordingly, by the economic characteristics mentioned in the formulation of the description of both development concept within the framework of the discipline design to cost management methodology based on value analysis, we are, as cost engineers for design engineering support, will mean the amount of direct cost for product components, leaving out both the life cycle and other economic indicators at business plan. The logic of naming the discipline shown on the slide is based on the term design to cost management methodology used in the MIL series of standards, as well as on the position of cost engineering as a type of value analysis that we discussed the previous slide. The set of names of the specialist of working group used in the definition reflects for design engineering orientation of cost engineering. The basis of project interaction within the framework of design to cost management methodology is a set of project data of the cost engineering system. Universal end-to-end project data include value analysis of value design engineering tools and individual united system of design documentation tools such as a table of analysis, a SWOT list, a report on the degree of novelty of the product, a list of purchase parts, a structural and functional model, and AQS diagram, data on customer satisfaction of functions and function carriers, data on quality of implementation of functions and their carriers, and etc. Specific profile end-to-end project data includes product tools used by relevant departments such as the option list and marketing plan for the marketing department, business plan, project charter, project contents, PSS, project scope statements, and etc. Instruments of project manager. Such instruments like PMP, project management plan, and a progress report for the project management division, design concept, industrial design concept, design engineering and design tectonics coefficient for the industrial design division, the division scheme, technical assignment, and other design and engineering documents in accordance with United System of Design Documentation for the design engineering department, and etc. A separate type of project data in cost engineering is EPD derivatives. Now, there are only two types of them, BOM and analytical reports. The meaning of the word derivatives in this case has nothing to do with the mathematical meaning of the term. Derivatives of the EPD are separated into a separate group and have an appropriate name due to the fact that, firstly, they do not make sense on their own, i.e. separately or independently from the EPD, and secondly, they must be adjusted based on the result of the adjustment of the EPD. Regarding the prerequisites for applying the design-to-cost methodology in the framework of a high-tech product development project, the following can be noted. This slide presents a list of standard problems that arise in the practice of the project implementation in the engineering industry, which to varying degrees can be solved by applying the proposed design-to-cost methodology based on value analysis. In terms of the task of substantiating the practical applicability of design-to-cost management methodology based on the value analysis, the logic is also quite simple. The basis for justification is the regulatory documentation listed on the previous slide and establishing the requirements for the project management system to be fulfilled within the framework of top-level terminology, namely the design-to-cost management methodology, which it was reviewed by us in the first slide. In addition, the justification of applicability is possible in the context of existing scientific publication. In this case, I would recommend that students refer to primary sources, namely the basic work of L.D. Miles and Yuri Sobolev, as well as the framework of the training course, Cost Engineering, and the practical examples value analysis given in this training course. The proof of applicability within the framework of the project working group and the tender committee working group, which are usually identical in composition and include the above-mentioned categories of specialists, is presented as the corresponding issues of the value analysis for cost engineering channel. In the issues of the same name, namely issues number 10 and 11, as well as the cases 1 and 2 for design engineer, issue number 12 is for specialists in quality management, issue number 15 is for marketer, issue number 16 for specialists in industrial design, issue number 17 for a specialist in project management, and issue number 18 for a specialist in commercial negotiations or buyer. This slide presents a list of professional standards and a list of relevant options for areas and training programs that correspond to the above list of specialists on the typical project working group, which in our case will consist of students of the relevant specialties. It's the use of such an end-to-end approach, or rather end-to-end project data, formed on the basis of the value analysis tools, and which will be mentioned separately below. In scientific substantiation of the applicability of design-to-cost management methodology based on the value analysis, the principle of choosing the optimality criterion is used by analogy. Firstly, with Eliyahu Goldratt's theory of constraints based on the search and management of the key constraint of the system, which determines the success and effectiveness of the entire system as a whole. And secondly, with the Gardner-Blackstone model when making a make or buy decision, where profit maximization is a criterion for optimal decision making. In accordance with this approach, optimal criteria for evaluating products from the point of view of project management are determined through the management of which it's possible to achieve increased efficiency. However, in the case maximum efficiency is achieved not by maximizing profits at the Gardner-Blackstone model, but by minimizing the deviation of actual design indicators from the set of values of end-to-end project data, or EPD, including the target value of direct costs as a milestone of the pre-project and the milestones of the project design engineering documentation. Means preliminary design and etc. i.e., to achieve such a state of product management system, the degree of organization of the project management system, in which the minimum allowable state of organization of the system is a state in which all internal working documentation of project departments corresponds to the end-to-end project data in accordance with the matrices of applicability in the areas. If it's quite simple to consider the approach using the example of structural and functional model, then we are talking about the existence of communication system between the project departments, in which if industrial design specialist has changed the structure of the product, i.e. he introduced a new system, aggregate or part, respectively, by changing the structural model, all project participants synchronously adjusted their internal profile, working documentation, and reporting by not in accordance with the change in internal industrial design department documentation, but only in accordance with the change of the end-to-end project data. For example, the design service adjusted the electronic structure of the product and design engineering documentation. The service cost engineer will change the AQS model and the list of functional carriers provided in it. A similar effect should be achieved if the marketer changed the option list, thereby changing the functional model, and etc. Saving of project resources with this approach is ensured by the fact that with minor changes, for example, of the mentioned industrial designer changed only the structural material or color scheme, i.e. the structural model remained unchanged. The participants of working group will not need to make any changes. We're talking about sensitivity of the end-to-end design data system. Here is a tabular matrix of the applicability of end-to-end project data, which within the framework of design to cost management methodology is a tool designed to visualize the applicability of universal and specialized design data to typical application tools of the main participants in the project team, i.e. design engineers, cost engineers, marketers, industrial design specialists, and the project office. The text of the cell in the cells isn't visible, not because I don't want you to read it, but because using the example of this slide, we will look at the general concept of forming this table, a simplified visualization of set of applicability matrices containing a list of main profile tools used in the coursework, and in which it will already be possible to disassembly will be demonstrated below. In the last section of our presentation. So, the basic activities of the product team, in addition to marketing the EPD applicability matrix, is a table that indicates the applicability of the EPD to various areas of the project team. Since we have 6 basic areas of the team's activities, project team's activities, there are also 6 applicability matrices respectively. In the vertical column of the left slide, of the left slide and of the table, we see the milestones of the project, and the horizontal row of upper part of the table, the profile, analytical, and applied tools of the design engineer, industrial designer, buyer, and etc. In addition, the block of parametric prices and techniques is highlighted in blue on the right side. There it is. On the right side of the upper line, which, as I have already mentioned, of the interest to the cost engineer, primarily of the pre-project and milestone of the project, design, engineering, documentation. At the intersection of the milestones and tools of interest to us, the applicability of the EPD is indicating the availability of a standard analytical form and application, for example, to a marketing plan, a link to standards, United System of Design Documentation form, and etc. In addition, this matrices contains links to training materials and cases of the cost engineering training course presented on the VLNL VA for Cost Engineers channel. Using the applicability matrix, the project specialist determines which specific EPD in addition to the mandatory universal EPD, can be used as a current milestone of the project as part of the application of a specific analytical tools for the marketing direction. Instead of the milestone of the project, the milestones of the formation of the marketing concept of the product, including the marketing plan, are indicated in the vertical column. This difference from the other areas is mainly due to the fact that the most time-consuming and expensive part of marketing analysis falls on the pre-project and on subsequent ones, at least for mechanical engineering. The volume of marketing analytical work is significantly reduced, therefore it doesn't make such sense to show this subsequent milestone. At the same time, the applicability of the EPD as a stage of pre-project can be considered in more detail. This slide presents a list of the main domestic and foreign regulatory documents on which the educational program designed a cost management methodology based on the value analysis is based, in particular standards in the field of cost engineering and value analysis. This slide doesn't list management standards that define the term design to cost, because they are quite extensive and most of the information contained in them doesn't relate directly to the area of our interest. An extended analysis of the set of regulatory documents used on the cost engineering is provided in issue number 14, VDI, Value Design Engineering Regulatory Support, Reverse Engineering, on the VA for Cost Engineers channel. The basic structure of the cost engineering department as part of the project support, it is presented on a slide. The quantitative composition may vary depending on factors such as the number of parametric pricing methods used, the degree of structural complexity of the product, and etc. For example, when developing a consumer drone weighing for 1 kilogram, obviously one cost engineer in the field of engineering and industrial design and one in the field of pricing will be enough. In the case of the development of a heavy reconnaissance drone weighing, for example, 5 tons, the number of cost engineers in the field of engineering and industrial design will correspond to the number of main units and system, for example, the frame, electrical system and cooling system, payload, power plant and control system, communication equipment. The number of cost engineers in the pricing area will not change in this case. In the case of the development of several conditionally large projects, there will also be more cost engineers in the field of pricing, while the number of cost engineers in the field of the engineering and industrial design will not increase in direct proportion. The third case, due to their narrow specialization in systems and aggregates. For projects involving the development of relatively small products, larger than a whoop but smaller than aircraft or submarine, it's possible to combine the function of the two types of cost engineer mentioned by one specialist. The presence of absence of specialists with an asterisk on the organizational structure is due to such factors as carrying out work in this area. For example, there is no marketing component in certain government of defense products. A mechanism for conducting commercial negotiations and selecting a supplier, as well as the volume of production and the corresponding list of technologies used, the availability of one-time costs for production equipment, and etc. R&D, and etc. Depending on the organization structure of the project team and the enterprise on the basis of which the project is being implemented, it can be created as a temporary or project specialist, so is a permanent product development support unit. The project to integrate the design to cost management methodology based on the value analysis into the project management system and enter the MVP or minimum viable process stage lasts about 6 months and includes the following stages. First, organizational stage, it's 1.5 months. Description of business process depending on the organizational structure of customer, it's 1.5 months too. And recruitment and training of newly hired and current staff, it's about 3 months. One-time contract work, project work is performed without preparatory measures. A detailed description of the integration of design-to-cost management methodology based on the value analysis into the project management system, as well as an expanded analysis for the cost engineering units effectiveness assessment can be provided upon request. Next, we will consider the complex issue of matching pricing methods and product development concepts, which we have already mentioned above. The degree of abstraction of the consideration of direct cost structure that the cost engineer used in his work, or more simply, expert calculation, and to make it even simpler, we will not consider CBD or cost breakdowns as part of the introductory lecture, since it refers to the second section of the lecture course. I suggest that we do not delve into pricing issues, in particular because this issue has been discussed in detail in the framework of free training video course presented on our products channel, VA for Cost Engineers. In my experience, I can say that most of the cost engineering departments currently operating in Russian enterprises are limited exclusively to aggregate and coefficient methods of pricing, which often results in extremely low accuracy in estimating the value of direct product costs at early milestones, while our toolkit, as you can see, is much broader. It includes methods that ensure greater accuracy of calculations, in particular a method based on value analysis data. Note that depending on the pricing method for the serial product used by our client, i.e. it's either a market method based on the assessment of the competitive environment or to cost, or method based on the amount of direct cost or cost plus. At the pre-project and project design engineering documentation stage, the project specialist cost engineer use the corresponding parametric price methods presented on the right side of the table, which with the of the slide, which the parallel formation of individual indicators using to cost and cost plus methods. And thus, at the pre-design and project design engineering documentation stage, parametric methods are not used in isolation, which makes it possible to increase the accuracy of analytics. For example, when using the aggregate methods mentioned above, we necessarily need a target market price and rate of return, i.e. we need data generated based on the two-cost methods. So, cost plus. Cost plus, currently the vast majority of domestic enterprises in the unmanned aircraft system industry operate within the framework of this pricing methodology. That is, the cost engineering department forms a BOM at each milestone and is actually limited to aggregate and coefficient methods of pricing, forming expert calculation and calculating the price of 1 kilogram of a drone, for example, and in first approximation, which often results in extremely low accuracy in estimating the value of direct product costs at early milestones and uncompetitiveness of products, since the target price of the product consists of direct costs, overhead, profit, and margin of the dealer. This is essentially the principle of what price we get and we sell at the price with an undemanding customer who is not guided by market prices for a number of reasons. This approach can be used but not on the open market. That's why our goal is implementation of the design to costs development concept, and can be achieved by using our main educational product, the design to cost management methodology, the options and effects of which we will consider below. Perhaps someone has a question: why is a direct cost? Why only direct costs and nothing more here? I answer, within the framework of the design to cost concept, the cost engineer doesn't deal with commercial and operational components of the product price on the life cycle. Cost engineer's area of responsibility, achieving the target value of direct product costs. In practice, this will mean the presence of an additional department of the design bureau or engineering company, engineering design bureau and companies with a big history, and now it's an engineering bureau, which will not produce design engineer documentation. We will be a source of additional overhead costs and will constantly distract designers, industrial designers, design engineers, marketers, buyers of the projects from their main work. The graph shows a simplified graph of fixing direct product costs by project milestones. Here, this project milestones. As we can see, already at the beginning of phase 4, here, i.e. at the stage of the beginning of the development of a serial design engineering documentation, the amount of direct product cost is already almost completely fixed in accordance with the selected design and technological solutions, and the remaining 50%, generally speaking, can be attributed both to calculation errors and to direct costs that can be adjusted as part of the application of approach, such as lean manufacturing, etc. Thus, the very concepts of direct cost management for a product makes sense only at the stage of development of a pre-project and a project design engineering documentation. Therefore, the cost engineering division only needs to be shown here, here and here. And then all cost engineers who do not have a family mortgage can be dismissed with clear conscience. It's a joke. Regarding as alternate use of the terms direct costs and pricing, the following can be noted in most cases. The object of the cost engineer's analysis is direct costs, in particular their relationship to marketing, industrial design, design engineering indicators, as well as the level of satisfaction and quality. However, since the cost plus, to cost, and parametric methods are mentioned in all sources precisely as pricing methods in the framework of practical activities, selling price and direct costs are usually considered as a conditional unified management object with the assumption that the indicators connect in them, such as the level of marginality, and firstly, we know the overhead costs, and secondly, they are assumed to be fixed. Let's consider some examples of the practical application of cost engineering tools, which will obviously contain concepts familiar to many listeners, such as a technical assignment, for example, change management procedure, and etc. So, the basic process of supporting the development of technical requirements or technical assignment product as a milestone of the pre-project and project design engineering documentation includes the list of works shown on the slide. Regarding the term reverse engineering, I would like to know the following. The varied definition of reverse engineering contains an indication that reverse engineering is copying the functionality of a product without directly copying of the physical medium. Thus, the most mentions of reverse engineering in a media or in science publication, i.e., in fact, the complete copying of components or products entirely by manual measurement or measurement on 3D scanner, generally speaking, is incorrect. Accordingly, we have cost engineering in its purest form when we applied a value analysis or design to cost methodology. You can get acquainted with the methodology and practical cases of technical requirements or technical assignment development, including reverse engineering methods on our channel. Methodology for assessing relative structural and functional novelty is used in the framework of project risk management for innovating products. Estimating of the labor intensity of design engineering documentation development, for example, in companies where there are no labor intensity standards, and third, the marketing analysis, competitive analysis, positioning, and pricing. Based on the results of the analysis, a basic report is generated indicating the degree of novelty relative to the base products of the previous generation, the distribution of the relevance of component and functions novelty factors at the required level of abstraction, as well as deviations from the acceptable level of product risks for the customer. The expanded report may contain additional analytical data of interest to the customer. You can find the methodology and practical cases for determining the degree of novelty on our channel. Further, these measures are verified in the context of end-to-end project data, for example, such as the basic value analysis tools as our RQS diagram, relevance, quality, implementation, and costs. This diagram, if we propose to measure, refers to a balanced component of the structure, then the possibility of its application is questionable, since in fact we will exclude well-designed components from structure, but if it refers to unbalanced one, then, as they say, it's on its way there. Thus, the use of end-to-end project data on the one hand gives arguments to design engineers and industrial designers to protect their successful design solutions, and on other, it doesn't allow the structure to conditionally freeze and provides cost engineers and buyers with arguments to exclude obviously unsuccessful design solutions from the design and thereby reduce direct costs for the product. Among other things, the RQS distribution data can be used as part of a point-based component assessment or point-based distribution of relevance in a structure. As part of the application of the design to cost management methodology, it's possible to provide services for the formation of measures to reduce direct costs depending on the project milestone. Accordingly, the most accurate and feasible measures can be formed at later milestones of the design engineering documentation, i.e. the preliminary design and technical design. We're talking about lower-level components, parts, assembly units. The practical implementation of the developed measures is carried out on the format of a special change management procedure, see the regulations, expanded in comparison with the requirements of GOST 2.503, i.e. the decision to make changes is made within the framework of the product's working group, according to the above-mentioned special regulated procedure corresponding in the design to cost management methodology. You can find the methodology and practical case for creating a list of measures to reduce costs for components at various levels using the factor, method of factor research, or MFR, on the value analysis, the VA for cost engineers channel. So this slide with a somewhat intricate title presents a logical scheme for the application of end-to-end project data in the framework of design engineering, documentation development, which, in my opinion, will be understandable to everyone and is, in fact, a typical logical scheme for practical application of EPD by the rest of working group, i.e. marketers, industrial designers, cost engineers, and buyers. Simplified, this scheme can be described as follows. The milestone shows a deviation from the target value of direct product costs on the basis of which the project manager gives instructions on the formation of an action plan to reduce direct costs. The next, the design engineering department, together with cost engineers, marketers, industrial designers, and buyers, from an action plan. This is where the classical approach ends and the design to cost management methodology begins. The action plan is formed in the MFR, or method of factory search format, within which specific technological measures are formulated. An example of the application of MFR is on our channel in issue number 9. For example, we have formed 10 measures to remove, for example, chamfers, increase roughness, reduce thickness, replace materials, types of coatings, and etc. Here, next, we must verify these measures and the content of the structural of the EPD of end-to-end project data. For example, the RQS, relevance quality, implementation costs diagrams. And the last step is implementation of the change management procedure in addition with the standards, with the normative documentation. Regarding the use of AI tools as part of the coursework, the following can be noted. The student, not being an expert in the field of developed object, can use the text interfaces of AI tools available to him in the process of forming structural and functional product models. For example, he can formulate an industrial design concept to describe the design engineering structure of the development object, such as what are the main structural elements of the drone, and for example, what aggregates and systems are part of the drone, and etc. What are the main structural materials used in the manufacture of micro drone frame, and etc. In terms of formulating the industrial design functions, it may sound what are the main drone frame functions, what are the main functions of the FPV video drone transmission system, and etc. Formulation of requests. Now let's consider a simplified visualization of tabular matrices of the applicability of value analysis tools within the framework of design to cost methodology. The screen shows a simplified visualization of the metrics of applicability of value analysis tools for a cost engineer, which meets the requirements for the role of cost engineer as part of the coursework. Below are similar slides describing the role matrix in many projects to develop a consumer micro drone for a design engineer. This is for cost engineer, this is for design engineer, for industrial design specialists, for marketer, and for buyer, or specialist in commercial negotiations. Here is the matrix for the project manager. So, thanks for your attention. Bye.